Welcome to the first module of this masterclass on advanced tropical forecasting. One of the most common questions weather enthusiasts ask is how to look beyond the 7-day model window. While standard computer models lose accuracy after a week, professional forecasters look at the heartbeat of the tropics known as the Madden-Julian Oscillation, or MJO. In this lesson, I am going to teach you how to decode the complex diagrams used by meteorologists so you can identify high activity windows for cyclone development weeks before they appear on a standard map. Think of the MJO as a massive pulse of rising air and thunderstorms that travels around the equator, taking about 30 to 60 days to complete a full trip around the world. When this pulse moves over a specific ocean basin, it acts as a catalyst, making it much easier for tropical cyclones to form and intensify. To understand the state of the MJO, we use a specific tool called a phase diagram. At first glance, this looks like a confusing web of lines, but it is governed by 3 fundamental rules. First, the circular chart represents the entire globe, divided into 8 numbered phases. Each phase corresponds to a specific geographical region. For instance, Phase 1 is Africa, Phases 2 and 3 represent the Indian Ocean, and Phases 4 and 5 cover the maritime continent near Indonesia and Australia. Second, the distance of the line from the center circle indicates the strength of the pulse. The center is the null zone where the MJO is weak or disorganized, but as the line moves further outward, the signal becomes more powerful and influential on global weather patterns. Third, the movement is always counterclockwise, tracking the physical progression of the pulse from west to east across the planet. For those focusing on the Indian Ocean or the South Pacific, identifying when the line enters phases 2, 3, or 4 is critical. When the ensemble members, the various potential paths shown on the diagram, cluster together and move deep into these phases, it indicates a high probability window for increased tropical activity. This is because the MJO is providing the necessary atmospheric lift that allows small clusters of clouds to organize into major systems. To supplement this, we also utilize velocity potential maps. These maps use color coding to show where the atmosphere is breathing. Green shades represent rising air, which is favorable for storms, while orange shades represent sinking air, which suppresses storm development. If you see a strong green signal overlapping with an active MJO phase in your region, the conditions are primed for a significant weather event. By mastering these diagrams, you move from simply following a forecast to understanding the global mechanics that drive it. I encourage you to visit a data source like Tropical Tidbits or the Climate Prediction Center to view the current MJO status. Practice identifying which phase the atmosphere is currently in and observe how the tropical convection reacts as the pulse moves into a new region. Understanding this cycle is the foundation of long-range forecasting. In the next module, we will build on this knowledge by exploring how these atmospheric pulses interact with ocean heat content to determine storm intensity. Thank you for joining this course, and I will see you next time.